In these tutorials, you'll learn about setting up the particle electron. You'll start out by pushing code and controlling it over USB, and then controlling it using the particle cloud. Eventually, you'll transfer ownership to our account, so it can be integrated with our KS server and our app. The goal is that you'll learn something along the way while also setting up a useful system. One quick note before we get started, the code that we'll be writing for the Electron is in C++. This example shows about as complicated as our code is going to get. You can see it doesn't involve a lot of the things that are tricky about C++. Really what we're just doing is creating variables, calling and creating functions. Most of these ideas are probably familiar to you if you're familiar with other programming languages, and you should be able to pick up on the syntax. But if you don't feel like you'd be able to handle this yet, go ahead and review C++ and come back and watch our video. To set up your Electron, you'll want to start out by going to setup.particle.io. You'll probably be redirected to this particle create account page. You can go ahead and fill this up and sign up for an account. Next, you'll want to choose Set up an Electron with SIM card. It'll prompt you to make sure you have a couple different materials ready. These should have all come in the package for your Electron, but make sure you have your Electron, your SIM card, the antenna and USB, and of course your battery ready. You can type in the ICC-ID number on your SIM card to activate it. You'll be prompted also to enter credit card information for your Electron, since its cellular data isn't free. Note that even though you're eventually going to transfer your Electron to us and have it associated with our account, you'll still always be having your credit card charged for its data. The pricing for the Electron's data is actually pretty economical. You can see here in the United States that your monthly fee is $2.99, and then the price per every additional megabyte is 99 cents. That $2.99 includes both just the monthly fee for running the Electron and your first megabyte of data. Any megabyte you use beyond that will be an extra $1. You'll probably stay under this first megabyte limit, but if you do go a little bit over, it won't cost you very much. You can monitor the Electron's data usage through the particle console, and you can always set limits if you want. That means there'll be an absolute cap on how much money you'll be charged for your Electron's use, no matter what. When your Electron goes over this data limit, it gets paused until either you raise the data limit or your next billing period starts. If you want to stop paying for the Electron data, you can also always just deactivate your SIM right from the console or contact Particle. For more information, check out the section on the Particle Docs site about Electron billing. They have all sorts of information about how your billing period is determined, how deactivation and pausing work, and more. After you enter the information for your card, you'll be prompted to follow the following steps. You'll slide the SIM card into your Electron. You'll also probably want to slide it back into its breadboard just to protect it. Attach the antenna. Connect the battery and USB cable. And then wait until it's breathing cyan. You may need to wait several minutes. And then you'll start claiming your Electron. And our final step in setting up the Electron is just giving it a name. Now we're ready to use it. Throughout this tutorial, we'll be using something called the Particle Command Line Interface, or CLI, to run code and work with our Electron. You can see here that I'm on the Tools and Features section of the Particle Docs, specifically on the section about the command line. They have pretty comprehensive instructions on installation. If you're on Windows like me, you can go ahead and download the installer. So I can just run Particle CLI Setup. Click Agree. You want to install everything here. And we can go ahead and close it. One last thing, you'll also have to change your environment variables. And I'm just typing into my search bar down here. So I can go ahead and edit the system environment variables. Click Environment Variables, go to Path, click New, and I'm putting in app data local particle bin. This is where the installer put my particle.exe file. Yours is probably in a similar place, but you just might want to check in this location just to be sure. Click OK, OK. close my environment variables. If you're not on Windows, you'll just follow these instructions for installing using npm. You probably already have Node.js, but you want to make sure that's installed. And then if you just run npm install -g particle CLI, the particle CLI will be installed. If you're having trouble, check out the other sections of the particle CLI documentation. Next, I'll open up my terminal. And now, if I type in particle, you can see that it's giving me some information about commands with the CLI. Finally, you'll want to run particle login and enter your email address and password. And then you're ready to run the CLI. We want to make sure that we can get a good cellular connection with the Electron. And actually the easiest way for us to do this is just to write a program for the Electron that will output the signal strength of the cellular connection. This will also be good practice in writing code for the Electron. I'm using my favorite text editor, Atom, but it doesn't really matter what program you use since we're really just editing a text file. You can see that this file that I have set up is an INO file type. You might recognize this as the file type that's usually used for Arduino code. You can see even my editor gives the little Arduino logo as its icon. You can run CPP files on the Electron as well as INO files. You're writing C++ code either way, but there's a little bit of additional setup, a few extra lines of code you have to add if you're doing a CPP file. So I'm going to stick with the INO file type for now. I'm going to add a setup function right now, which does one thing. It's going to say serial.begin. This is how we're going to read our output from our Electron. The reason we want to use serial is that, for one, it's easy. The particle CLI has a serial monitor built in. It also means that we don't have to worry about pushing data through the cellular connection to somewhere that we can then go look at it, because the whole point is that we're not sure we have a good cellular connection yet, so we probably want to have a way of communicating with the Electron that doesn't rely on cellular. Next, I'm going to set up a function called loop, and then I'm going to say cellular signal sig equals cellular.rssi. Cellular.rssi is a function that returns a cellular signal struct which contains information about our cellular connection. RSSI stands for Receive Signal Strength Indicator, and that's mainly what we're going to be looking at, the RSSI. We can just go ahead and say serial.printf RSSI equals, and then %d, because the RSSI will be an integer, and then we say sig.rssi. Oh, and we'll want to add a new line afterwards just to keep things neat. So hypothetically, this is enough for us to see the straight up RSSI for our Electron's cellular connection. But your connection might be really jumpy and hard to interpret, so I'm going to add something for us to average it. Before I go ahead and explain it, I'm going to first add the constants that we're going to use. If you notice, alpha plus beta will add up to 1. I'm now going to set up the variable that we're going to store our average value in. I'm going to initialize it at 0. So the way this works is I'm going to say average RSSI equals alpha times sig.rssi, so that's our new value, what just came in and what was just measured, plus beta times our old average. So you can see what's going on here is that slowly, if we had the same value from our cellular RSSI, over time our average would slowly approach our raw value. But if our sig.rssi is jumping around a lot, our beta is so large compared to our alpha that hypothetically our RSSI should be smoothed out into a value that's more easily interpreted. And of course, we have to add it to our printf. And make sure you say %f, since average RSSI is a double. Finally, just to make sure that we're not inundated with values, I'm going to add a small delay at the end. This is in milliseconds, so this is going to end up being a delay of 1 second. Our values will update pretty frequently, but not so quickly that we can't keep track of the old values. Before we load our code onto the Electron, we have to compile it. I'm going to use the particle CLI. So you can see right now in my directory, I just have my electron.ino file. I'll say particle compile e and then electron.ino. So the E means that we're compiling it for the Electron device specifically. Alright, it's compiled successfully. Now, before we can push our compiled code to the Electron, we have to put the Electron in device firmware upgrade mode, or DFU mode. And the way that you do that is you can see that there are two buttons on the Electron. There's the mode and the reset button. I need to hold down both of them. Go ahead and release the reset button only, and you should see a blinking purple mode first, which unfortunately in this video is covered up by my finger. And then once you see the blinking yellow mode that corresponds to the Electron being in DFU mode, go ahead and release the mode button as well. Now I can deploy my compiled code to the Electron. I simply say particle flash and then --USB. You should of course make sure that your Electron is connected over USB to your computer, and then the name of that firmware file that was generated. You can see that this was what the output from the compilation was, so that's the file that I'll say. I've now deployed my code. You can see that the mode changes color on the Electron as well, and it's now breathing cyan, which is the slow blue blink. To access my program's output, all I have to do is look at it on the particle serial monitor. It's just a built-in part of the CLI where you can view the serial output. You can see on the left, I have my raw RSSI, and on the right, I have the average. For me, my raw is pretty stable, and I don't maybe need to pay as much attention to the average. You can see the average is also slowly approaching the raw because it's that exponential averaging. But if yours is jumpier, you might want to pay more attention to this. -59 is a pretty good value. You want to aim for above -95. If you're having trouble, there are a couple of things you can try. If you try positioning your antenna to face one of the 4 compass points, north, south, east, or west, you might get a better signal. If that doesn't work, you could go to a different side of the building, maybe even tape the antenna to the side of the window. If that really doesn't work, you could always try a different location. Also make sure that your battery is plugged in, not just that you're powering the Electron over USB, because the cellular often performs better when it has battery power. Alright, I'm about ready to actually start writing my code. I'm going to start out with creating a variable, which I will put my LED pin number in. I'm choosing D7 because that's what the built-in LED on the Electron is hooked up to. Next, I'm going to create my setup function. It's just going to be void setup, and then I'm going to call pin mode with the parameters LED and output. So that's just saying that we're going to make the pin that our LED is connected to an output pin. Next, I'll say particle dot function, and then pass it two things, the string LED and then LED toggle, which will soon be the name of a function that I've made. So what I'm doing when I call particle.function is I'm creating a function which will be named LED when I want to access it from other places like the particle console or the particle CLI or command line interface. And then the code that that's going to correspond to is going to be found in the function LED toggle, which I will set up right now. So if it's one of the particle functions, it has to return an int. And then I'm going to have it accept the parameter command, which will be a string. If the command is on, we'll say digital write LED high. So that's setting it high, that will turn on the LED. I'll then say return 1. Otherwise, if our command is off, I'll say digital write LED low and return 0. Finally, if I get something unexpected, I'll just return -1. I've already compiled and pushed my code to the Electron, just like we did when we were testing out our cellular connection. It should be the exact same procedure for this code, so if you don't remember how to do that, go ahead and rewatch that section. After we've pushed our code, to actually call our function, I'll use the command particle call, then the name of my device, mine is called demo electron, and then the name of the function as we named it when we called particle.function, which if you remember is LED, that was the string that we passed, and then finally the parameters, or the parameter in this case, which is just on. So you can see that that took a second, but now the onboard LED on the Electron is lit up. You can even see the return value from the function right here. And I can turn it off in the same way. Unlike with the onboard LED, we'll have to do a little bit more complicated wiring to control things with our relay. So I'm going to draw it out for you here first, just so that you have an idea of where we're going before we actually do it. The 3 pins that we'll be using on the Electron are the 3.3 pin, which is a high power pin, the ground, and the D7 pin. If you remember, D7 is the name of the pin that the onboard LED uses, so if we plan on controlling things with our D7 pin, then we don't even have to change our code. I've also added some holes here which represent the holes in the breadboard. Remember, holes in the same row are connected, as if everything plugged in there is wired together, and holes in the same column are not. First, we'll take our LED that came with the Electron and plug it into the same row as the 3.3 pin. We'll take the short end and put it in one of the empty rows at the top. We'll take our resistor, which also came with the Electron, and plug one side of it into the row with the ground pin on the Electron, and the other side into a different empty row. Then we'll connect these 2 rows with the relay. The idea here is that when the relay closes, the LED and the resistor will be connected along with the pins they're plugged into, and the LED will light up, but when the relay is open, the whole circuit will be open and the LED will not light up. The relay itself also needs some pins connected. It has power, ground, and then the pin that we will control it with. We'll go over all of this again, of course, as we plug things in, but try to keep this in mind as it might keep things less confusing. I have my Electron ready here. I don't actually have to write new software to control the new components that I'm going to hook up, but we do of course actually have to wire them together. You can see actually that I have my Electron plugged into the breadboard that came with it, and I have it off center because I want to have a bunch of holes right here ready next to each other. I want to make sure that I have a bunch that are available in the same row. That's because in the breadboard that anything that's plugged into the same row is connected, and anything that's plugged into the same column is not. So if you want to hook 2 things together, you just plug them into the same row. I'll start out with the LED that came with the Electron. You'll notice that it has a long side and a short side. I'm going to take the long side and stick it in the same hole as the 3.3 pin on the Electron, and I'm sticking a short side in one of my empty rows at the top. You notice that I actually have 2 rows up here at the top which aren't connected to anything, or at least aren't connected to any pins on the Electron. Next, I'm going to take my resistor that also came with the Electron. I'm going to stick one side. Let's see, let me straighten this out. You can see that I have one side in the same row as my ground pin, and one side in my other empty row at the top. So you can see that the resistor and the LED aren't actually connected because they're not plugged into the same row. You can see I have one of these Grove relays ready here. You might have a different kind. It doesn't really matter as long as it works as a relay and you can hook it up to one of your GPIO pins. But the important part is that I have my 2 male-to-male wires here. I'm going to plug them both into my relay. Plugging them into the green holes here means that they'll only be connected when the relay is turned on, and they'll be disconnected when the relay is turned off. Now I'm going to put one of each of these wires into the same row as the LED and the resistor. Each of the LED and the resistor had a side in an empty row, and I've put the wires that come out of my relay into each of those empty rows. What you can see is going on here is that when the relay is closed, this will form a complete circuit, so this LED can light up, and when it's open, nothing will be connected. I now have to wire up the relay itself so I can control it as well. I have 3 more male-to-male wires ready right here. You can see that they have colors that about match the colors of this cable here. So I'm going to plug my black male-to-male in there and plug it into the row with the ground, because of course my relay needs ground as well. I'm taking another one of these wires and plugging it in right there. You can see it's plugged in so that it matches up with the red wire on my relay that I know is hooked up to its power. So I'm now going to plug that in also in the row that's connected to the 3.3 pin. So I've just hooked up the ground and the power for the relay. And you can note that actually my wire here doesn't quite match the color of my cable. It's orange, but it doesn't really matter. It's just close enough that I can tell. I have my yellow male-to-male, which I'm going to plug in to connect to the yellow cable right here. And this cable is the one which actually controls whether the relay is closed or open. When I set the pin high, the relay closes and the circuit completes, and when I set the pin low, the circuit opens. So I'm going to plug it in to hook it up to D7. And if you remember, our program lets us turn the D7 pin high and low. So now we're ready to actually run our code and light up the relay. I have my Electron ready here, connected to its battery. You can tell it's running normally because its status LED is breathing cyan, so it's connected to the cellular network. To light up the LED, I do exactly what I did before. I don't even have to worry about pushing new code. I just say particle call demo electron LED on. And there you go. You can see that it lit up the onboard LED, which is connected to D7, but this super bright light here, which isn't even showing up very well on the camera, is actually the LED. And you can even see that on the relay, it has its own onboard LED, which tells us that indeed the relay is closed. Just like before, I can easily turn everything off by saying particle call demo electron LED off. And there you go.